Hello everyone, welcome back to Zenith Integral Academy, and in today's class we are going to be looking at block diagram and transfer function. Please make sure you like my channel, subscribe to my channel, and at the same time comment, and I'm open to feedback. So let's get started. The reduction of a control system to a block diagram greatly facilitates the analysis of the performance of the system or response. And each of our block represents an element, and our element can either be a forward path element or we should have a feedback loop element. Now, the transfer function of any element is the ratio of its output signal all over its input signal. That is, our output signal all over input signal is equals to our transfer function. And now at the same time, this our transfer function, which is equals to output signal over input signal, can as well be expressed in some other forms, which include the transfer function, which is equals to output signal all over input signal, can as well be expressed as equals to WNN square all over A square plus 2 damping ratio WNS plus WNS square. Similarly, I can have my output signal all over my input signal to be equals to K all over JS square plus FS plus K. Now this is the first form. Let me call this 2. So we can express our transfer function, which is the ratio of our output signal all over input signal, in this form, or at the same time we can as well represent it in this form. The numerator, which is your WNN square, this WN is same thing as our angular velocity, which is expressed in radian per seconds for any given system. The numerator is where we have the gain of the system, the gain of the control system. And the denominator, if I should equate by denominator to 0, I'm going to be having my characteristic equation. Don't forget, the numerator is the gain of the control system. If I should equate this my denominator to 0, it's going to give me my characteristic equation. Now under our control system, as we know that we have classification of control system. Our control system can either be an open loop control system, or it should be a closed loop control system. At the same time, it can be a cascade loop control system. For the open loop control system, corresponding feedback will not be gotten about the state and condition of the system. You can't analyze it, you can't predict it, no corresponding feedback. While for a closed loop, there is corresponding feedback, you can analyze, and at the same time you can make your prediction so as to improve the efficiency of your system. Cascade is just like a combination of your open loop and your closed loop system. So now the next thing we are going to be going to now is representing our control system when you're using block diagram, when they are connected in either series or parallel connection. So this is what we are going to be having. Now we have this, our control system when they are connected in series. Now take a look at this block diagram. We have G1, G2, G3 representing my element. I have my RS representing my input signal, while I have my CX representing my output signal. And don't forget that, look at the direction of the arrow. I told us that whenever we have this kind of arrow facing forward, we call it a forward path direction. Where we have another arrow that can either be facing backward, we call it a feedback arrow. Now we need to take note of these two things I'm going to be explaining now. We have a rectangular box and we have a circular box. Now for this rectangular box, let's assume I have an element denoted with G4. I have a a corresponding input signal denoted with what? Theta high as my input signal. Now, for whenever you're having a rectangular bus and an element is there, rectangular is known with multiplication. That is, your input signal or any element that is coming in, if you should multiply the elements in the rectangular plus G4, is going to give me an output signal of G4 theta high. Meaning that what? Whenever you have a rectangular bus, you have an input signal multiplying an element in a rectangle. My resulting answer is going to be multiplication. Is going to be something like this, G4T1. For a rectangular, we multiply, while for a circle, it's either it should add or subtraction. Let's assume I have an input signal of theta I, and at the same time I have an element of, let's say, G2, both of them feeding in inside the system. My corresponding output element is going to be plus of G2, then minus of what? Of theta I is going to be the output signal. So in the first one, my input signal theta Y is feeding my G4, which is going to multiply it and generate an output signal of G4 theta high. And the second one, whenever you have a circle, is either it should be positive or negative. Your theta input negative and your G2 positive, feeding it, I'm going to be having plus of G2 minus of what? Theta 1. Your circle is either addition or subtraction, while your rectangular bus is used for what? For multiplication. So now let's find the given transfer function for this block diagram. Here, RS is going to be serving as an input signal for G1. So if I should multiply these two, I'm going to be having a corresponding output signal of, let me denote it, A. Now, this A now is going to be serving as input signal for G2. Multiply it is going to give us an output signal of what? Of B. B now will serve as input signal for G3. If they multiply, I'm going to be having an output signal of what? Of CS. So now let me now analyze it. So I'm going to be having my first one, which is my A, to be equals to, if RS multiply G1, it will give me my A. So we can write it G1 RS. Always make your G1 come forward. So let's call this my equation 1. Similarly, if A should multiply G2, it will give me an output signal of B. So B will be equals to G2A. And that's the same thing as G1 G2 RS. Equation 2. Sorry. And similarly, if my B should multiply my G3, I'm going to be having an output signal of CS. So I'm going to be having I'm going to be having my CS to be equals to BG3, and that's same thing as G1 G2 G3 RS. Let's call this 3. Now, since we have this, look at the final one. I want to find a relationship of getting transfer function of output signal all over input signal. And my output signal here is denoting as what? As CS. And my input signal here is denoting as what? RS. So this is what I want to have. So you divide both sides by RS. Divide both sides by RS. So this take care of this. So I'm going to be having CS all over RS to be equals to G1, G2, and G3. So meaning that whenever I'm asked to find using block diagram to find the control system that are connected in series, the resulting answer is going to be what? A multiplication of your element. So in the next video, I'm going to look at control systems that are connected in parallel and some complex block diagram. Thank you.